definition. The slope is the ratio of the vertical change, or rise, and the horizontal change, or run, between 2 points on the surface. Slope is also called the rate of change.
So our main idea is that we are going to describe the steepness of our line. Steepness of slope describes the steepness of it. So when we measure slope, you might be thinking like of a hill, a mountain, a road, roof, if we're thinking of the slope of something. You're going to take a look at this next table as you look in your notes, and it says we want to find the rate of change. So the rate of change is going to be the change in distance is what we are looking at. So a lot of times you might think of this as being your x-axis, so time is x and distance is y, okay? And it's almost always an xy table, so if you wanted to think of this, this is kind of an ordered pair, right? X, y, okay? So if we are looking at this and we're looking at the rate of change, I might take my first number, my second number, 520, and I'm going to subtract the change in distance. The distance before was 260, and I'm going to divide it by 2 divided minus 1. So I'm looking at that change, 2 minus 1. So 520 minus 260 gave us 260, right? Over 1. We want to see if this is constant. Now there's a couple of different ways we can see if it's constant. So we're going to check another one. So we're going to take the 780 minus 520. And at 780, that was at time of 3 minutes minus the time of 2 minutes, which is when we had a distance of 520. 750 minus 780 minus 520 gives us 260 again. If we are looking at this, is that the same rate of change as we go from 780 to 1040?
Yeah.
Yes, because here we are adding 1, and this is another addition of 260 if we are looking at it. So it says, is the rate of change constant as we are looking at this? So we would say, yes, our rate of change is constant. It's 260 feet for every minute. 260 for every minute. And it says, describe what it means in this context. So just the 260 per 1 is what we're looking at. And in this context of this situation, we are talking about 260 feet per every minute. So the band marches 260 feet every minute. You are going to be asked to interpret slope quite a bit as we do these problems. So when you look at this, not just having the number, but what does that number mean? And in this case, it means that our band was marching 260 feet for every minute. Okay? So, this is the graphs of ordered pairs, time and distance. So a lot of times, if we talk to that next page, so we have T is our time, comma, D is our distance. Is that the same as if you would have an X, Y? Yes, as you are looking at that. They just use those variables of T for time and D for distance. It says the relationship between time and distance is linear. When data are linear, the rate of change is always going to be constant. Notice that you also have a rate of change found in problem 1. It's just the ratio or vertical change, which we refer to as our rise, to the horizontal change or our run between 2 points. Rate of change is called the slope of a line. A lot of times you might see, instead of vertical change and horizontal change, rise over run, you might see this where they use this triangle, and they talk about it in the video just a little. It's called delta. And a lot of times it'll say change in this case, we are going to look at y over the change in our x. So linear functions have a constant rate of change or slope as we look at this, and I'll get your question in a few minutes, but I just kind of want to get through part of it. If you were graphing these different points at 0, 1, 2, 3, does this make sense that this is a continuous graph and not discrete? Because you can march for 1.5 minutes, right? You can march for 20 seconds. You can march for 3.5 minutes. So this is a constant or continuous graph if we look at that. So the slope of the line of a graph just counts the vertical change. We went up 260 units as we went 1 unit to the right as we are looking at that. Let's see. I can't remember. I thought there was a video on one of these. Top of the next page. Yes, that's right. All right, so we're going to look at our rate of change. If we are looking at this one, the rate of change in a table, the easiest way to do it is we are looking at our change in, so if we're thinking of time, and in this one we are looking at water in the pool, so we'll put gallons, right? That's what we're looking at, gallons left, so time to gallons, right? So we're going to take a look at the change in gallons that we had divided by our change, in this case, of time. Change in time. So change in gallons over change in time. Change in gallons, we are going from what? 80 minus 60 divided by 20 minus 10. Does that make sense? It has to be 10 minus 20, right? Because we put 80 first. We have to have 10, which goes with the 80, minus 20. Now, if you would have started the problem out differently and said 60 minus 80, right? Then you would have had 20 minus 10. In this case, we are going to have 20 divided by a negative 10, gives us an answer of negative 2. If we are looking at this one, 60 minus 80 would have given us a negative 20 divided by 10, still gives us negative 2. And if you think about this one, what's happening to the water in our pool? Could be evaporating, but there could be, if you think of like a swimming pool in your backyard, like a little tiny, those plastic ones, it could have a leak, right, or a crack, and it's water slowly going out. So in this one, what is our slope? We would say that our slope, or our rate of change, was equal to a negative 2. We would say in this case a negative 2 gallons, right, per 1 minute. I'm going to have you hold off on your questions, okay? So as we look at this next one, anytime you're looking at a graph, key thing for our rate of change, it's the change vertical. It's our vertical change. Can you count how high up you're going? That's our rise. Can we count how high up we are going in this case? We went up 2 units, right? Okay. And then it's our change horizontally. And our change horizontally is 1. So we're looking at rise over run, 2 over 1. So we would say in this case that our slope, our rate of change, is equal to 2, and in this case, if we were going to label it, we could put 2 over 1, but for the situation, we would want to say $2 per pound, right? So if you're always putting it in the context of the problem, okay? All right. So it says you can use any 2 points to find the slope. We decide the distinguishing by 2 points, and we usually use x sub 1 and y sub 1. For the second points, we're using x sub 2 and y sub 2. Does it matter which one is x sub 1 and which one is x sub 2? No. Usually they go in order from left to right, so they'll put the first one and the second one, but it doesn't really matter. And then this is the slope formula that's down here. And we're going to watch this video. It's not too long, and they kind of explain this one more time. This formula you will need to memorize. You will be using this, so you want to memorize the rise over run, y2 minus y1 over x2 minus x1. And this part is really key. This can never be 0, and we'll talk about that as soon as we're done watching this video. Yeah, I know. The play button's right underneath my other.
Rise is how much. Slope is defined as the change in y divided by the change in x. There are multiple formulas for slope, so
slope.
let's look at
So
them.
let's look at them.
First, we'll look
First,
at rise,
we'll look at rise
over, run.
over run.
Rise is
Rise
how much we move
is how much
up
we
or
move
down
up
on a
or
graph.
down on a graph.
And run
And
is how much we
run
move
is how
left
much we
or
move
right
left
on a
or
graph.
right on a graph.
In other words,
In other
rise
words,
is the
rise
movement of
is
the
the
y
movement of the
coordinates,
y coordinates.
and run
And
is the
run
movement of
is
the
the
x
movement
coordinates.
of the x coordinates.
Now I mentioned
slope
slope is the change in
is
y
the change in
divided
y
by the
divided
change in
by
x.
the change in x.
We can represent
We
it like
can represent
this.
it like this.
Triangle y
Triangle
over
y
triangle
over
x.
triangle x.
This triangle
This
is
triangle
delta.
is delta.
And in math, it
And in
just
math,
means change.
It just means change.
So we have the change in y divided by the change in x.
The change in x.
Now if we're finding the
Now,
change
if
in
we're finding
y,
the change in y,
that means that
that
we're
means
taking the
that we're
difference
taking
between
the difference
two y
between
coordinates
two y
on a
coordinates
line.
on a line.
So
So
on our line,
on
we
our
find
line,
two
we
y
find
coordinates
two y
and then
coordinates
find their
and
difference.
then find their difference.
That's the change in y.
That's the change in y.
Same thing with the change
Same
in
thing with
x.
the change in x.
We find the difference
We
between
find the
two
difference
x
between two
coordinates
x coordinates
on a line.
On a line.
So we have
So
multiple
we have
ways
multiple
to
ways
represent slope.
To represent slope.
Slope is equal
Slope
to the
is
rise
equal to the rise
over the run,
over the run,
the change in y
the
over the
change
change
in
in
y
x,
over the change in x,
or y sub 2
or
minus y sub 1
minus y sub 1
divided by x
divided
sub
by
2
x
minus
sub 2
x sub 1.
minus x sub 1.
Kind of depends on your situation as you are looking at these. So when we are looking at those, kind of always is going to depend on our situation for which one we're going to use. Some are more appropriate than others at different times. So those three different methods that we are looking at. So if we're looking at the slope of the line and we're given 2 points, if you look at that bottom page of your notes, right? If we are looking at this one, this is really, if we are looking at this one, you can see that they have x1, and then this is like our y1. This is our x2, y2. Sometimes I will have students write that right above because it seems to be more helpful than writing it to the side. Shh, quiet, please. So if we are doing this, we are subtracting our 2 minus 2, which gives us 0 over 5. Anytime you divide 0 by any number, it gives you 0. So anytime you have a slope of a horizontal line, your slope is going to be 0. If we are looking at B and we have a vertical line, first off, is this a function? No, because it doesn't pass the vertical line test that we just did. And when you subtract here and you take -2 minus a -2, and again, for some of you, my hint will be to rewrite that minus to plus the opposite. Gives us a 3 plus the opposite, we get 0. You can never divide by 0, and if you leave this for an answer on your homework, I'm going to mark it wrong. 3 divided by 0, any number divided by 0, you want to leave this and write undefined. So I know they have it down here, 0 is undefined, the slope of this is undefined. Your answer is undefined. So when we were talking back here about why this can never be 0, the reason that that denominator can never be 0 is that division by 0 is always undefined. Easy, simple quiz question. I ask it often as we go through this unit. Division by 0 is always undefined. Okay? So you got to get that down as you are looking at those. So on the top of the next page, we are given ordered pairs. If it helps you to designate above each one, that this is your x1, y1, your x2, y2, we are not going to graph any of these. You are simply going to use your formula. So we're going to start, and as you do your homework, I want you to write down the formula. Slope or m equals, so m is the variable that they use for slope, kind of helps us with movement. Slope is our movement when we think of graphing, okay? So we are going to take, in this case, we're going to write our formula. So we want to write y sub 2 minus y sub 1. And it is sub 2, it's not y squared, minus y sub 1 divided by x sub 2 minus x sub 1. And I would say for the first half of the problems that you do in your homework, I need the formula written. Why? You have to memorize it anyway. Best way to memorize it is to practice writing it. So if we are looking at this one, we're going to take 2 minus a -3 divided by, we're going to take our 4 minus 4. 2 minus a -3 is the same as 2 plus +3. We get 5 over 0. our slope should be undefined. So again, you're going to start that next one. M equals. Start with y sub 2 minus y sub 1, x sub 2 minus x sub 1. As you look at the problem, -3 minus a -3. I might already be thinking, I know what the answer to this one is, right? Some of you seen our answer? I'm going to put in my denominator 5 minus a -1. That minus a negative, again, when you are looking at that, changing it, if it helps you to change it to adding the opposite. For some of you, that is going to be your saving grace. It's going to help you to not make silly mistakes. 0 divided by, in this case, 6, which is 0. And if you put it in your calculator, this will always give you 0, and this will always give you an error on your calculator. And yes, there is a huge difference on these two. This one is a function because it's a horizontal line. This one is a vertical line. It's not a function. It's still a straight line. It's just not going to be a function if we look at it, okay? So it is still linear. It's just not a function, okay? So let's go down to the next one. Owen, question? So we're going to start with the next one. Y sub 2 minus y sub 1 over our x sub 2 minus x sub 1. I will tell you that yesterday as I started correcting the tests, I'll talk about it after this. So you're going to do 3 and 4. Okay? So do 3 and 4 right now. You're going to learn by getting it right? So we do not want to have 2 minus a -1. Those are my x coordinates, right? Or it could have been these two. We can't do that. We need to look at, so Mallory, start me out, and I'm going to have what?
-3.
Yes? Minus 2. And in my denominator, then I'm going to have what? Keep going. 2 minus. Yeah. Now, if I put -1 and not that minus a -1, that's going to make a big difference, right? Mm-hmm. So be really careful. And again, I might look at this problem and go, oh, I hate subtraction. I'm changing subtraction to adding the opposite. And I get -5, right? And I go plus the opposite, and I get -5 over 3 as my slope. Everyone get -5 over 3? Okay. Can have a negative slope. If we're thinking of that line, if I would have plotted those points, it's kind of going like this, right? -1, 2 is over here, 2, -3 is over here. That is a -5/3 slope as I'm looking at that, okay? So we're going to the next one. y2 minus y1, again, over x2 minus x1. Anyone want to volunteer to start us out? Abby, you want to give it a shot? 2 minus 0 over 3 minus -2. And I'll tell you, there's just really small errors that people will make in this. If we are looking at this, we have our y2. And so do you have to write x2, y2? No. But I'll tell you, for some of you, especially at the beginning of this, it will help you out immensely if you do that. So we're looking at 2 over, and in this case, we should have a positive 2/5. And if you think of graphing that on the coordinate grid, we'd go to -2, 0, and then we'd be at 3, 2. And if you think of that line, that probably is a positive 2/5. It's going up to the right, okay? So, when you look at slopes of lines, positive slope always goes up to the right, okay? Negative slope goes down to the right. Horizontal is 0, okay? Undefined. So, last year, I believe, didn't I do it with you guys too? Pre-algebra, help me out. Slope band.
Oh, yeah.
Yeah?
I think
So that base, oh, Mr. Lehman was doing it in your class, right? So, positive slope, right? Negative slope.
undefined.
0 slope. And undefined, right? Here's my view, okay? So, if I think of this, anytime I'm figuring out my slope, and I'm looking especially at a graph, if the line goes up to the right, it's a positive slope. If the line goes down, it has to be negative. If you don't get a negative, you want to check what you did, right? Then we're going to have undefined, and then putting those circles at the end tell me that the 0 is horizontal, okay? this is just something easy and quick to put on the top of a quiz or on your paper as you're doing your homework to remember what your slopes look like, okay? So, you are working on page 298. As you are looking at this, they just ask you to determine the constant rate of change. Find if it is, find the rate of change, explain what it represents. So when you do number 8, after you find that rate of change, you need to tell me in words what it represents. So just like that first example. Here, the easiest way to do slopes is to simply count, right? So when you're doing these problems, I would not use the formula, right? I mean, you could, but the key thing is for 11 through 7 through 16, you should be looking at the rise over the run, okay? When you get here, it's to find the slope of each pair. This is where I need the formula. M equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So, you are working on the problems 9 to 41 on. These go really fast in here because you should be counting rise and run, okay? When you get to this page, and as you are doing your homework, check your answers in the back. Do a couple questions